So we continue. Okay. Iron at 20 degrees C is a body center cubic. Okay, BCC, and with atoms of atomic radius 0, 1, 2, 4. Okay. Calculate the lattice constants A for the cube H of the ion unit cell. Okay. Can you do this one for the example one? How we can do for the BCC? What is the A or the lattice constant for the cube? Okay, if you done it, can you do? For those who are still not doing, so I give you about 5 minutes. Okay.
Doctor, I cannot find the Padlet link in the chat.
Tak ada. Dekat chat tu tak ada.
Tak ada, doktor. Tak ada.
Ni. How about this one?
Dah. Dah.
Okay. Okay. So if you look at here that, okay, just rearrange this equation. Okay. So once you rearrange the equation, you can get a relationship between A and R. A is equal to 4R divided by okay. So this one 4R divided by square root 3 into A. So you just substitute this radius into R. So you can get the answer. Okay. Easy, right? Okay. So what's the answer for A? 0.286. Okay, Lukman already answered. Okay, 0.286. Please look at the Padlet. You can see, right? Okay, so thank you, Lukman. Okay, so how about these tutorials? Okay, molybdenum at 20 degrees C is a body centered cubic, has an atomic radius 0.140. Calculate the lattice constant in nanometer. It's similar. Okay, since it's BCC, okay, so the equation is going to be similar. Okay, so the equations A is equal to 4R divided by square root 3. Okay, so please answer. What's the answer? A is equal to 0.320. Okay, so the answer is 0.320. Okay, okay, how about the 2? Calculate the value of atomic radius of a gold atom in nanometers. Okay, how do you do this? What is the relationship between R and A? So please refer this center cubic. Okay, what is the equation for the A? Okay, so if you look at here, this one is FCC. Okay, so the relationship is A equal to 4R divided by square root 2. Okay, so just substitute the radius. Okay, so give me the answer for the tutorial. as well as please do also for tutorial. Please verify how you can get this FCC is equal to 0.74. Tutorial 1 and tutorial 3. So this one is from the equation from the previous slide. Okay, A is equal to. Oh, but this one is we have to find R, right? Because the lattice constant is 0.4700. Okay, so that means but the relationship of 4R equal to square root 2. Okay. So please find R. Anyone? Anyone can post in the Padlet? What is the answer? And also verify the atomic vacuum factor of the FCC. Please verify this one. So 0.74. 74% is occupied by the metal, while the rest is the void or space. Nobody post in the Padlet? 0.286. Wrong. Lukman. 0.144. Okay. 0.1442. Okay. So the answer for tutorial 2 is 0. Should be in the latest one. So please verify the APF for FCC for the tutorial 3. Can you verify? So if you want to verify, you can just refer here. Okay. FCC crystal structure. Okay. With the lattice constant equal to 4R divided by square root 2. Okay. So okay, with the four atom unit cells. Okay. For atom unit cells, volume atoms, okay, just substitute into the equation for the volumes and lattice constants, volume for unit cells. So APF equal to 0.74. So that means this means that 74% of the unit cell is filled with the metal and 26% is empty space. Okay, so this is how you verify. Okay, just refer to that. If for the other crystal structure, CC. Okay, so you have to refer to the SC. Okay, so that is for the how to calculate the atomic vacuum factor. Okay, the like coordination number. Okay, the lattice constant for each crystal structure. Okay, simple cubic, body center cubic, as well as phase center cubic. So have to know for that part. Okay, what else? What is the definition of the crystalline solid? Okay, as well as non-crystalline solid. Okay, and then type of unit cells you have to remember. Okay, there's a 7 different unit cells. Okay, and then based on the Bravais, there's a 14 standard unit cells, so you have to remember. for the unit cell, cubic unit cell, tetragonal, orthorhombic, and so on. All those things you have to know. Okay. So any question about the cubic crystal structure? Any questions? I think it's quite easy, that one. Before we move to the direction and Miller indices. Okay, I think so we just focus on the direction indices. How to determine this the direction of the atoms or the unit cell. Okay, the position of and the coordinate. Okay. Okay, if you have no questions, okay, we move to the next part. It's about the crystal structure of the metals and ceramic. Okay, so atom position in the cubic unit cells. Okay, we want to locate the atom positions. Okay, so we call it as a Cartesian coordinate system in a cubic unit cells. Now, please remember this one. Y-axis. Okay, y-axis is the direction of the to the right. Okay, this one. Okay, this is the direction to the right. Okay, this is y-axis. X-axis is coming out of the paper. Okay, this one is toward uh, uh, out of the paper, while z-axis is towards top. Okay, this one. So you have to remember this axis. Yeah? Negative directions are to the opposite of negative direction. So if your definitions for y direction here is a positive, okay, and this direction should be negative. Similarly, also for x. X, this one is positive, and that one is inside the paper, negative. This one is z direction is positive. Okay, and the bottom, like toward the bottoms, this one is negative. Okay, so if you look at here, okay, atomic position are located using unit distance along the axis. Okay, please remember this one. Okay, in the cubic unit cells, okay, vector component of direction resolve along each axis, reduced to the smallest integer. If your answer, if in the, what is it, okay, like this one, 1 divided by 2, you have to convert it into integer. Okay, or 3 divided by 4. Okay, this one in the fraction form. So you have to convert it into integer. So you have to remember that. And generally we represent as a square bracket without comma. That one you have to remember. Okay, for example, this one, bracket 1 1 2. This one is for direction, but for Miller indices it's gonna be different. Okay, we're not using a bracket. Okay, but we're gonna, what is it, we're gonna present by using, what is it called, if Miller indices is more to plain, this one, this bracket, this type of bracket. Okay, normal bracket, not square bracket. Okay, okay, so okay, for example, this one is your origins. You define this one as origins. Actually, any points you can define as a origin, or we define as new origin. If you want to use this one as new origin, you have to define this one as new origin. Generally the position, this one, okay, the what is it, the position is 0 0 0. Okay, the origin, okay, the coordinate for the origin. Okay, and if you get here, this one is the tail, okay, and this one is the tip, arrow tip. Okay, represent the direction of the atom. Okay, the position is 1 0 0. You have to remember that this one is 1 0 0. Okay, because this one is x, 1 is x, y is 0, z is 0. Okay, right, because it's only one direction to the x axis. There's no direction to z as well as no direction to y. Similarly also for this one. Okay, x, y, z, because no direction for x and no direction for z. The direction is only along with the y axis. Okay, similarly also for this one, along with the x axis. There's no directions for the y as well as x. Okay. So this is what I highlighted. Okay. How to find the direction indices. Okay. This is the procedure to find the direction indices. Okay. Produce the direction vector till it merge from the surface of the cubic unit cell. Generally, I will I will sketch this box so that we can know. For example, this box. Okay. So we can know we can have idea or we can imagine which direction which direction of the target atoms. Okay. And then for example, this one. Okay. The origin is here 0 0 0. Okay. And then determine the coordinate of point of emergence and origin. So if you look at here, this origin is 0 0 0. Okay, while for the emergence or the arrow tips towards the directions. Okay, so we can see here that x axis. Okay, x axis is 1. Okay, this one is x axis. Y is equal to half of 50% of the y axis. Okay, because this one. Okay, this is just half of the y direction, but it's full for the x direction as well as full for the z direction. Okay, so x, y, z. So the emergence is going to be 1/2 and 1. Okay. So subtract coordinate of point emergence by that of origin. So this one you have to subtract. Okay, this one the emergence to that origin. 1/2 1 minus 0 0 0. So and then we okay. Similarly 1/2 1. And since the answer we have to convert it to all integers. Okay, so you have to times with 2. Okay, so this one we have to times with 2. Okay, since we want integers. So once you times with 2, okay, so we can get 2 1 2, and then you have to convert it into bracket, and there is a negative direction or not. Since there is a non-negative direction, okay, so the answer is going to be 2 1 2. Okay. Okay, hence okay, your answer is going to be like this one. Okay, so there's a bar number. Okay, so represent the indices in a square bracket without comma with this one is a bar over negative index. Okay, generally we represent it. If there is a negative direction, so you have to put bar here. For example, this one is numbered. The number. Okay, similarly also this one is everything is positive. So just square bracket without comma. Okay, all the direction is positive. So look at here for the example 2. Okay, determine direction indices, okay, of the given vector below. Origin tail coordinates are 3 divided by 2 0 1 4. Emergence arrow tips coordinates are 1 4 1 2 as well as 1 1 2. Okay, how can we determine this direction indices? Okay, so from the procedure, okay, we have to subtract coordinate of the point emergence by the origins, since we already know the coordinates. Okay, so we just keep to this step. Okay, just subtract coordinate of the point of the emergence by the origin. Okay, okay, once we subtract, okay, for examples, this is the emergence. Yes. 1 4 half and 1 by 2. Okay, minus with 3 4 0 1 4. Okay, so the answer is negative half half and 1, 1, 4. Okay. So since we want the answer in the integer, so we have to multiply with 4. Okay. So this one we can get negative 2, 2, and 1. Okay. Okay. So when we want to represent the answer, so we have to represent like this one. Negative 2 bar 2, 1. Okay. So this is your answer. Okay. So you should present in the brackets without comma. Okay. Good answer. Okay. You understand? So that means again here, okay, the direction is to negative 2 to 1. So this is what we call direction indices. Okay. Of direction indices, we look at here. Okay. For example, this one. Okay, this is the origin. This is 100. So this is 110. Why 110? Because x 100% is for x and 100% for y, but 0% for z. Okay, that's why this is 110. How about this one? Everything is 100%. Z 100%, x 100%, y 100%. Okay, so 111. Okay, and this one 210. Look at here. This is the origin. So this is only half of y, right? And 50%, 50% for y. Okay, it should be 1 half 0. Okay, before we convert to integer. So because only 50% for y direction and 100% for x direction. Okay, so if you look at here, this is we have a new origin. Okay, so the direction of the arrow is opposite. If you look at here, is a negative for x axis. Okay, if you define this one as a, okay, like this one. Okay, this is a y, this one is x, this one is z. If you define a new origin, so that means y-axis is going to be negative. Okay, x-axis is negative and 0 for z, because you define this one as a the origin. Okay, similarly also for x. If you define here, right, as a new origin, okay, so x is going to be negative, okay, y is a 100% and z is equal to 0. Okay, and this one, okay, 50% of the x-axis, okay, as well as 50% for the x-axis. This one 50%, but 100% for x-axis. It should be 1, 2, 1, 2, and 1. Okay, before we convert it into integer. Okay, similar also this one. Okay, I hope you can understand the all the directions at the positive or negative, 50% or 100%, and as well as 1/3. Okay, or 3 divided by 4. Okay, so all these things you have to familiar. Okay, so let's see the example of the example 3. Okay, direction indices also. Determine the indices for the direction shown in the accompanying figure. So if you look at here, that the projection of the vector out to the x, y, and z axis. Okay, if you look at here, this one. Okay, if I sketch here, so just I take this one, right? Okay, so from that one to this one. Okay, and then so this one is half. Okay, what else? This one is 100%. 1 or equal to p. X-axis. This one, right? Y-axis. And half for the x-axis. Okay. Then 0 for the c. Okay, this one is c. So that means the z direction is equal to c. C equal to 0. Okay, so we can become A divided by 2, okay, B as well as C. Okay, so it can be half, 1 and 0. So multiply with number, multiply with 2, so we can get the answer. Okay, the answer is 1, 2, 0, and we can represent as 1, 2, 0. Okay, so this is the another example. Okay, so that's the example. Okay, how about example 4? Draw 110 direction within a cubic unit cell. Okay, so this one is he give the direction indices. Okay, 1, 1, 0. Okay, 1 minus 1, 0. Okay, how can we draw within the cubic unit cells? So what you have to do, okay, the answer is given the direction in the value. Okay, so what you have to do is you have to sketch, okay, in the x, y as well as z. X, y as well z. So we know is this one actually is 1, -1 is equal 0, right? Because it's already in the direction. Okay, so I will draw the box. Okay, if you look at here. Okay, I will draw the box. Example, this one. Okay. If our origin is here, we define this one as origins. So 100%, this one 100%, 100%, but negative direction, and this one is 0%. Okay, 0%. This one is 0%. So that means x is going to be this direction. Okay, how about y? Y is going to be this one, since this one is positive, so it's going to be this direction. Okay, okay, that direction. Okay, so it's going to be this one 100%. How about z? Z is 0%, so that means it should be this one and this one. Okay, and your direction is here. Okay, this one is the position of 1. This is the position 1, 1, 0. Okay, in the bracket. Okay, okay, so that's position. So you can redraw this box again. Okay, the box till we know the direction on the left side. Okay, so we draw the box. Okay, this one, this one. Okay, so we define this one as the new origin. So toward this direction, 1, 1 minus 0. Okay, so this is new origin. Okay, to the left. So this one is y. Okay, and this one is y. This one x. This one z. Okay, so this is the position of the box. Okay, or the unit cell for for the direction indices 1, -1, 0. Okay, so you have to redraw the new box. Okay, so this is the example. So the box, it should be this side. Okay, you can move this box to the left. Okay, any question about this before we do the tutorials? Okay, I hope all of you already understand. Okay, if you have no questions, so please do this tutorial for A, B, C as well as D. Can you do now and post in the Padlets?
Doctor, I have a question.
Yes.
Uh, how do we know the origin of the vector?
If for example like this one, okay, like this one, right? It is given the direction vectors already. Okay, what you have to do is to draw first. You have to sketch first. Okay, you have to sketch first with the unit cell. For example, like this one, you have to draw the box first. Okay, right. So that means Z. Okay, this one is Y, this one is X. If you look at here, this one, 1 is equal to -1 and equal to -1. Okay, so if you define first this one is origin, you define this one as a first origin. Okay, the direction is going to, you define first your origin anywhere, but generally this one. Okay, this is the origin. Okay, you define first. For example, this one, X is equal to positive, right? So your direction is gonna here 100, and then -1 is not going to be to the right, but it's going to be to the left. -1, 100%. As for Z, okay, Z is not towards to the bottoms, negative. Okay, so your direction should be here. Okay, isn't it? So you can imagine which is your origin as well, which is your the direction actually based on this box. Okay, and then you can move this to the bottom. Okay, so you withdraw again, you draw again. So that means this is your new unit cell, the position of your unit cell. Okay, so you draw like this. Okay, so this is how you determine your origin. Okay, just find first your origin is here. Okay, by sketch x, y as well as z, and then you can move the new, you can determine the new origin. Okay, is it answer your question?
Oh yes, doctor. Thank you, doctor.
Yes. Okay, so just define your origins here first. 0, 0, the position is 0, 0, 0. You can define your new origin. Okay, okay, any questions? So please do this one already. I have I already give you the answer. Okay, please do for B, C as well as. Okay, this one is the direction. It should be. The answer is like this one, right? When defines. Okay. For A, right? Okay. So your answer is like this. So you define this one as origin. So it's towards this direction. Okay. So this is a 1, 1, 1. Okay. For A. How about B, C as well as D? So I hope there's an answer in the Padlet. Okay, everybody have to, I think I don't think test. Uh, Definitely Miller indices as well as direction indices is gonna. Okay. So our test one is we already decide on to 11 Wednesday night time. Okay, for test one. S D. What is it? 212, I think. Yeah, 212. Sorry, 211. The test one is 2 December. 2 December. Oh, sorry. The test date, yes, 2 December. Lukman, this one part B. Okay, part B. Let's see. Okay, I share. Wait. Okay, I stop this one. Let me share. Let me share. Okay, Lukman. Okay. Okay. So Lukman, so please do not forget to. Okay. Since this one is zero. Okay. Get here right. This one is the the origin is 0, 0, 0. Okay, so you define this one is the origin, the origins, and you define new origin. So please do not forget to put the number or the directions. Okay, so that means this one was 0. This one, sorry. So this one is 0, 0, 0. Okay, and this one is 0, 1, 0. Okay, this one is new origin defined by Lokman, and this one is a emergence arrow tips. So you have to write also 1, 0, 0. Okay, so this is a for B, which is 1 minus 1. Okay, so you have to remember this one. Okay, you have to write down. Okay, this number or this
Okay.
number position. Thank you, Lukman. Okay, don't forget.
Okay. Okay.
Okay, good. Okay, so but the answer is right. Don't forget this one. What is it called? The coordinate. Okay, the coordinate number. Don't forget the coordinate number. Because you define, generally we define this one as the original origin, and this one is a new origin. So if you look at here, right, 100, if you want to check, okay, 100, okay, minus with 0, 1, 0, 1, 0, okay, we can get the answer is 1 minus 1 and 0. So that is correct. Okay, your position is 1, 1. Okay. The question for B actually. Is it 1 minus 1 or 1 1 1? Oh, sorry, this one it should be 1. Okay. 1. Should be 1. Okay. Okay. So it's correct. Okay, so this position is correct. Lukman. What else? Any else? This one, Andy, I cannot see Andy. It's so small. Oh my god, it's so small. Can you repost? I cannot see Andy. I cannot see Andy. It's too small. Maybe you take one picture big like a Lukman. I think this one is big. And this kind. It's too small. I cannot see. It's okay. Anyone else? I cannot see them. It's very small. And please write if you answer B, C, or D. Okay, which question did you answer? I cannot see any. Okay, Andy. That we just. Oh. Uh, C and D is similar answer. The to put the we have before we stop. Anyone? Almira, okay. Biasanya yang perempuan ni tak ni Fatina, Izatu, okay, Nur Elin, Christina, Sarah, Vira, apa lagi? Anissa. Can you answer? Senyap je. Tahu tak tahu ni?
Doktor boleh tengok, can I see the question?
Oh, see the question. Okay. Saya dah. Nur L Ain. You post already, Nur L Ain. Tak ada pun sini Nur L Ain. Sekejap question. Yeah. So in part B, why we not start from 000? Lukman, can you explain why we not start at 000 to Tahsin? Already explained, right? Lukman, why we not start our origin at 000?
I make it a new origin because if I start from 000, the arrow will be outside of the box.
Yeah.
So to make it easier
Okay.
to draw.
Okay. So we define a new origin. If you start from 0, your direction is not going to be 1, 1, negative 1, 0. Okay. So it's going to be different direction. Okay. So this is the question. That's why it's important to define a new origin. Okay. The answer. Okay, Almira. Just now I see your answer, Almira. L. Okay, L. L for C. The direction is okay. It's a negative 1 to 1. So when you convert it into the Cartesian coordinate, this one, okay. So we can get negative 1. So we can get negative 1 half for C, right, Almira? Negative 1 negative 1 half and negative 1, isn't it? This is the coordinate, okay, for C. Okay, so how can we determine this direction, this coordinate? Okay. Okay, so the answer is okay. So if you look at here, okay, dah dapat soalan. Look at here, I stop sharing this one. The answer from L as well as with Almira. This one from this one. Okay, since who's this L, right? Where is L? Yes, you define this one as a origin, right? Look at here. If you look at here, right? You have to you have to be careful with the the uh with the answer. Okay, since our target is negative 1, isn't it? The answer is negative 1, right? Negative 1. Oh my god. Direction is 1, 2, 1, right? Is it correct? Right? I forgot the question. Let me see. Okay, so it should be negative. What's the answer? What is the question? Negative half to negative 1 to negative 1. Okay, so the direction is negative 1 to negative 1, isn't it? So actually this is equal to negative half. Okay, 1 negative half. Okay, so this one you have to divide it into 2. Because for the box, okay, the length is 100%, or we define as a only one. Okay, this one. Okay, this one, the length is everything is 100% or equal to 1. Okay, so we cannot more than 100% or 200%. This one is equal to 100. So that's why we have to divide by 2. Okay, divide by 2. So we can get this one. This is the direction. Okay. So let's see from the origin. Okay. From this one. Okay. Erase all. So what I did is I will draw the box. Okay. Almost finished our class. Okay. So this is you define as a z. This one is y. This one is x. Okay. So look at here. This is your new your origin. Okay. Origin is here. Okay. So inside is negative half, and then 1 negative half, x, y as well, z. Okay. So negative direction for x is going to be this direction. So if this one is 100%, it's only 50%. So this one is 50%. And then x is positive. So this direction, 100%. Okay. As well as what else? This one is 100%. This one 50% for the x, as well as 50% for the z-axis, but negative. So that means down here, let's go down here. Okay. So this one is 100%. This one is 100. So this one is going to be 50%. So your direction should be here, as well as, okay, going to be, we draw new box here. Okay. So this one we define as the origin. If we define this one as a new box, it's so difficult to draw here. So from that one, once we define, okay, so we can get this one. Okay. Okay. Alright. Okay. So we can get this one. So betul lah nak lukis kat sini. So half for x, okay, 100% for y, and 100%, no, 50 for z. So that means only half here. We define this one. Okay, toward this direction. Okay, so this is the direction. Okay, so difficult I want to draw here. So I give you in the Padlet the answer. So we finish our class. Okay, and this one is the answer I give you. So if you have any questions, I give you in the I think it's a WhatsApp group. Any questions? Because it's quite difficult to draw here. Okay, so I just give the answer. Any question?
So, Doctor, I want to ask.
Yes.
So, if the question is like in tutorial 4, we have to make two cubes. per
Tutorial
one
Which one?
answer. Per one. Let's say we choose tutorial 4
Uh-huh.
part B or part C, same lah.
Uh-huh.
So we have to draw the first cubic with the origin 0, 0, 0,
Yes.
and then we make another cubic with the
Mhm.
new origin.
Yes, that is correct. That is correct. Okay. Because the first cubic is to imagine which your actual direction actually, right?
Yeah.
And then you can define the new origin from that first block.
Mm.
Okay. So that's you can define the
Mm.
actual for me. You have to draw first using the orientation, and then you have to
Okay, dokter.
right.
Doctor, the new origin is up to us.
Is it clear?
Clear, dokter. Thank you so much.
Doctor, question, doctor. Is the new origin up to us?
Clearly mouse. Okay. 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 You by yourself. Okay. Yeah. It's up to you actually. I think you want the first origin first before you define. Okay. So the origin first. Okay. To which you the new address. Thank you very much, guys. See you. For those who still not scan the attendance,